like I said, pretty typical. This is like a good entry level question in like grade 11 physics when you get there. Okay. Maybe some grade 10 science. Might see this in grade 10 science. So Billy's mother sends him to the corner store for milk and tells him to be back in 30 minutes. Okay. Examine the graph and describe Billy's progress. First of all, did Billy get in trouble when he got home? Yeah, how long did it take him? Kenneth? Took him 40 minutes. Okay. Now, there could be any number of reasons why it took 40 minutes. That's what we're going to get into here. Okay, because this graph could honestly look like anything, and we could maybe draw a different scenario on the same graph to depict a different situation. Okay, but for right now, there are some things asked here that answers are like hidden, if you will. Okay, so we're just going to kind of try and untie what's going on with this particular graph, because there is lots of information here. You just might not necessarily know it yet. Okay, so let's start at number 1. Why are some line segments on the graph steeper than others? It's a good valid, like, just looking at it, why is it different? Different spots are different. Kenneth?
Because maybe Billy doesn't walk at a constant speed or just gets lost or something.
Okay. Yes, that's valid. That's one valid. Ollie, do you have a point maybe?
Never mind. Sorry.
Okay, that's all right. Yeah, Hazel?
Well, at one point they realized they were going to be like late. And
Which point would that be maybe?
for my one thing that
F to G? Yeah. Maybe any other, like, anything? I don't think we've necessarily like answered the question here. Well, Hazel kind of danced around it, but why are the lines different steepnesses? Yes, Opal?
The speed is walking.
Okay, the speed he was walking. Now, there's something you've said in there that I think you all are going, after I show you, it's going to make sense. But I don't know if you're I think you're glossing over the fact that on here, you can actually find the speed by looking at this graph. Even though it's measuring distance and time, you can find the speed. Okay? And so Opal's statement there about the speed is true. And so what I might conclude is, at some points he might be running, some points he might be walking. Does that make sense, everybody? Okay, and at some points he realizes he's late and then he starts to sprint. That's the reasoning for the different steepnesses. Okay, so Billy walking, running, or sprinting. Okay. Questions, comments, concerns? This is where I think things get interesting. Opal mentioned speed, but we didn't talk about how could we extract speed from this graph. Kenneth?
Distance divided by time.
Okay, so I think you've all ridden in a car before, or a bus or something, and on the sides of roads, there are what? Signs that tell you to do what? The speed limit signs. And underneath or on those speed limit signs, what are the units? Opal?
Kilometers per hour.
Okay, so it could be miles per hour too, but in Canada it's always kilometers per hour. So this gets to what Kenneth is talking about. We have distance. That's what kilometers are in terms of dimension. Do you remember me talking about dimension early on in the course? Maybe not. It might have been grade 10. I can't remember. Over, and what's hours? Hours is a measurement of what? Yes, Elizabeth? Time. Well, look at that. Look at the labels on our axes. we have distance, and which axis is distance on? Elizabeth? The y-axis, and time is on the x. So, if I were to pick 2 points, like A and point B, and I found the change in their y's and the change in their x's, what is that? I know you've all seen this before because we had a little conversation on the Greek alphabet. Hazel? A slope. It's the change in the y divided by the change in the x. That is y2 minus y1. Okay? And so if we take the final distance, so we'll say like d final minus d initial, and all I'm doing is changing y into distance because that's what's on the y-axis, d for distance, divide by x2 is time 1, or sorry, if I want to find the final time or how long it took and I subtract off the initial time, that'll tell me how long it took me to do that. And conveniently, when you do this, this is what do you think? What are the units? I just told you what the units were over here, right? Distances and time. What does that equate to? What is kilometers per hour or distance over time? So this is speed. That's speed on a distance time graph. Oh, yeah? Yep. Does anybody have any questions? So when I come down into like number 2 here, and I find the slope of AB and the slope of BC and the slope of DE, so on and so on, I'm actually finding how fast Billy was moving. Because that's the slope on a distance time graph. And anytime because I teach physics, there's 3 different graphs in reality. We can have distance time graphs, we can have velocity time graphs, and we can have acceleration time graphs. And the thing that saves me all the time is I fall back on what is the slope on the graph that I'm looking at. Okay, and the slope, depending on the units on the axes, tells me what I can read off of that graph. Okay? I always look at the units on the axes. For you, it's always going to be distance time. You don't need to worry about anything. It's very easy for you because it's just distance time. If I find the slope on a distance time, it's the speed. Okay? You don't have 3 graphs to think about right now. Okay? Grade 11 physics, you'll start talking about all 3 graphs. How to produce them and bounce between them. But anyway, that's not the point. So let's find the slopes. Okay, slope of AB. Remember, a line segment is denoted with there's a point A and a point B, and there's a line segment between them if we connect them. And so this is how we would denote it. So we could go, okay, well, we could take y2 minus y1 over, actually, you know what? Let's not do y's. Let's use distances because that's what we're on. So let's say d2 minus d1 over t2 minus t1. Okay, and obviously B in this particular instance is going to be all the 2's. And A is going to be the 1's. Would everybody agree? So I'm just kind of reading left to right and what happens first and then so on and so on, okay? So let's look at the points then. I'll erase some stuff so we can see. Okay? So let's read off the points. B has a point of 4 and 200. And A is obviously at, I'm going to assume 0, 0. Okay? No time, no distance away from his home. Everybody happy with that? So the slope for this one's not too bad because when I go to plug this in, D2 is going to be 200, take away 0 over 4 take away 0. And so we're going to get 200 divided by 4, which is what's 200 divided by 4? 50, that's it. Okay, now, I want you to be careful. 50 what? We've had conversations around units before. It's definitely not 50 elephants or bananas or whatever. You gotta be careful. Okay, Elizabeth, what do you think the units are? Okay, it'd be very easy for anybody to go 50 kilometers per hour because we're like, oh, that's what I'm used to. Or like 50 meters per second. But do you have any idea how fast 50 meters per second is? Woof, that's fast. Very fast. So be careful with the answer that you write down on your page because the units can either, albeit that numerically you are correct, the units make your answer physically impossible sometimes. Okay, and where do I get my units from? Well, they're right here on the axes. Meters and time in this particular question is measured in minutes. Because this whole time, maybe we should have been writing units in. Not a big deal that we didn't. But just be careful with the fact that like on top, for distance, we have meters, and on the bottom, we have minutes. And so I'll move that up so you don't see. So then we can say, okay, well, when I divide 200 meters by 4 minutes, I get 50 meters per minute. All right? So that's how fast Billy is moving from point A to point B. Does anybody have any questions? What we're going to try and do here as we move around is to compare all the speeds, right? And then based on your knowledge of slope from y equals mx plus b and graphing lines and all the stuff we did a few weeks ago, and slope, dude, puff, puff, positive and nice negative, right? The steeper something is, the faster Billy must be moving. Okay? And vice versa, the shallower something is, the slower they must be moving. Does that make sense? Because they're covering less distance for the same amount of time. So it must be moving slower. Okay? So, if you want to hit stop here, you can run through this. Okay? I'll leave that as part one. That was a